Okay. Again, what I think most of you have determined is the best way to do these is to just create a table of values to start. Because otherwise it's a lot to keep track of and to try and manipulate the parent function. So I think a lot of you have found the table of values to be most helpful. Okay. How do you know what table of values to use? Well, it's all based on whatever the parent function is, and in this case our parent function is sine, right?
Yeah.
Okay? If all you were doing was graphing your sine curve, like if all this said was y equals sine x, what would be your coordinates that you would plot to help you draw a nice sine curve?
0.
We got 0, 0,
Pi over 2 over 2.
pi over 2,
That's what I meant to say. 1.
1,
Pi. 0.
pi is back to 0,
3 pi over 2.
that's down at -1, and then we're back. Okay? So, that's what I would start with. Start with your parent function. Start with the values that would help you graph your parent function. Okay? Remember that ends up looking something like this. You don't need to graph this right now. I'm just refreshing your memory. Okay? So there's your parent function. What's the amplitude of the parent function? 1. What's the period of the parent function? 2 pi, because that's how long it takes to complete one wavelength or one cycle. Okay? What's the midline of the parent function? Y equals 0. Y equals 0 is the horizontal line that's going right through the middle of the wave. Okay? Alright, what questions do you have on the parent function? Ask right now, because without understanding the parent function, it's going to be hard to understand all the different things we're going to do with that parent function.
This is the original parent function.
This is y equals sine x.
Yeah.
Yep.
Okay. And I mean, okay. Yeah. Yes. What I'm wondering is in this problem, is it pretty much the exact same thing except shifted up 4 units?
No, there's a whole bunch of things that are going to affect it.
It's a negative.
It's going to have a new amplitude, it's going to have a new period, it's going to have a phase shift, and it's going to have a midline shift.
Yeah.
It's going to have all 4 things. Okay? So, this is my parent function, y equals sine x. Then there's a lot of things that we have affecting the parent function. Remember the day where I showed you on the calculator how each value affects the parent function?
Yeah.
Okay? A little refresher. This showing up on the camera.
Yeah.
Okay? Thanks, Parker. The A value affects what?
Amplitude.
Amplitude, or in other words, the height of the wave. The B value affects the period. The period is always 2 pi divided by B. The period is always 2 pi divided by B. How do you figure out your phase shift, your left and right phase shift? You set the parentheses equal to 0 and solve for the variable. That's how you find your phase shift. And then how do you determine the midline? That's this value back here. Okay? Alright. So what I'm going to do is I'm going to start adjusting these coordinates of my parent function based on the values that are given to me in that function. Okay? I like starting with amplitude. In fact, I'll just probably work with the y values to start with. Okay? What values here, the -2, the 3, the pi over 2, or the 4, which of those values affect the y values of the parent function?
The 4.
The 4 does. Yep. And the -2 does. Okay? Because the -2 is going to be multiplied by whatever this is. and then at the very end you're going to add 4. Okay? So I would recommend doing your amplitude first. Okay? Because my a value is -2, every one of these y values needs to be multiplied by -2. In this case, I'm multiplying by a -2. So 0, -2, 0, +2, 0. You have to raise your hand if you have a question. So now, if this function, if all it said was y equals -2 sine x, so if the only thing that was different was this -2 from our parent function, then here's what your graph would look like. It would go down here, back up here, and back down here. Everybody see how the amplitude increased and it started going negative first? How do I know those coordinates? Well, I can see them. 0, 0, 0, 0. Pi over 2, -2. Pi over 2, -2, and so on. Okay? So that's how the a value affects the parent function. It made the amplitude a larger number in this case. And it also made it start by going negative first. How are we doing? Questions so far? Okay. Now, let's just stay with the y values. Let's get our new midline. What am I going to have to do to get my new midline, or to make sure that this takes effect? Add 4 to every y value. So 4, 2, 4, 6, 4. Really, what does that do to the green one that I drew over here? Just takes it and slides it up 4 units, right? You guys with me on that? If you're just adding 4 to the y value, it's going to shift everything up 4 units. Okay? So now I've taken care of my amplitude, I've taken care of my midline, but now I got to take care of the other things, the period and the phase shift. What is the period? What does changing the period do to the graph? So if this is how long it took to do one cycle, changing the period will either scrunch it together, right? Or pull it apart. Make it be longer waves, or make the waves be very, very short. Okay? So let's figure out what our new values would be after applying what the period is going to be. How do I determine the period again? 2 pi divided by b. So in this case, the period will equal 2 pi divided by 3. So in other words, it's going to complete one cycle, one wavelength, in 2 pi over 3 units, 2/3 of a pi units. So what do I need to do to my x values then to make sure I complete one period in 2 pi over 3 units?
Divide by 3.
I'll always divide them all by 3, right? Because the original function took 2 pi units to go through one cycle. But now we want this to be 2 pi over 3. So what did I do to go from 2 pi to 2 pi over 3? I divided by 3. So let's divide them all by 3. 0 divided by 3, still 0. Pi over 2 divided by 3. Times 1/3. Pi over 2 times 1 over 3. Pi over 6. Pi divided by 3. Pi over 3. And 3 pi over 2 divided by 3, or times 1/3.
Just pi over 2.
3 pi over 6, which would reduce to pi over 2. Okay? So now, I've taken care of the period, but this one also still has a phase shift. Okay? To determine my phase shift, I need to take what's in the parentheses, the 3x minus pi over 2, set it equal to 0, and solve. So let's add pi over 2 to both sides, and then divide by 3. So my phase shift is pi over 6, which means what?
Move it to the right.
The graph will be shifted to the right pi over 6 units. Because a phase shift is a left or right shift. Okay? Because when I solved for my variable, I got a positive pi over 6. This graph is going to just move pi over 6 units to the right. So what am I going to need to do to all of these x values to determine their new location? Add pi over 6. If I want to move something to the right, I need to add to the x values, right? Okay? So now we'll really get into some fractions. Okay? So I'm going to add pi over 6 to each x value. Well, 0 plus pi over 6 is pi over 6. 1 pi over 6 plus another 1 pi over 6 makes 2 pi over 6, which would reduce pi over 3. Everybody okay?
Shifted down.
Okay. Pi over 3 plus pi over 6. You might want to make the denominator become a 6, right? How do I make the denominator become a 6?
Multiply by 2.
Multiply it by 2. So that'll give me 2 pi over 6 plus my 1 pi over 6, which makes 3 pi over 6, pi over 2. My next one, I got to take pi over 2 plus pi over 6. So pi over 2 plus pi over 6.
Times 3.
Take this times 3. So 3 pi over 6 plus pi over 6.
So
4 pi over 6.
2 pi over 3.
2 pi over 3. And last one, 2 pi over 3 plus pi over 6. Multiply by 2. So 4 pi over 6 plus 1 pi over 6.
5 pi over 6.
5 pi over 6.
I'm noticing something. Well, actually, no.
It worked out in this instance where they just kind of all shifted.
It over like 1, 3,
So then, if I need to graph this, okay, looks to me like these are counting by pi's over 6, right? That's 1 pi over 6, that's 2 pi over 6, 3 pi over 6.
Yes, you do.
So I can call that one pi over 6. The next one would be 2 pi over 6, or pi over 3, pi over 2.
We added 6's before.
At pi over 6, I'm up at 4. At pi over 3, I'm down to 2. I'm not going to have room, shoot.
Should we write our design as 4?
Yeah, our midline is y equals 4.
Okay, maybe
This
you're
is
right.
gonna be our midline, right?
But can we just put it on there, or would we have to?
No, slide it up.
Okay.
Yep, slide it up, I'm sorry.
Oh, yeah, that was.
There would be a graph of one period of this function.
So then, even though we really mainly use midline and phase shift to figure out how we're gonna graph this, does it still count as graphing like the whole thing then, since we had to use X and Y to figure that stuff out?
Yeah.
Okay.
Yeah, that's,
Okay.
yep. Now, if I said you had to graph more than one period, well, then you need to just, you can still use this, but just keep counting, you know, by pi over 6. And you know the pattern now, right? I mean, it would just keep down and back here, and then up, and then back here, and then down, and so on, right? Okay? Any questions on that? Okay?